Yes, this is where we stopped last time, question number 15. So do you have any question until this point? Yes, can you hear me? Is it okay? So, okay. So yes, thank you very much, because just want to know some answer that at least I'm audible. Yes, I'm clear. My voice is clear to all of you. Yes, Ahmed Ibrahim, am I audible? Can you hear me? Yes, thank you very much. Okay, now this is where we stopped last time. Okay, thank you, Ali Yusuf, thank you. Now we stopped at this question number 15. Now we look at question number 16 and some other questions, right? So what is question number 16? I'm going to share the question. Now what is question number 16 is future worth and project balances, right? Now if you look at question number 16, it says consider the following investment projects, and in year 0 there is a cash outflows of minus 55,000. Year 1 it is an inflow because it is positive 42,500. Year 2 44,600. Year 3, year 4, year 5, we have different types of cash flows. It is not an equal series, it is irregular or unequal series. In this question we are required to calculate the net future worth of the investment at 14% and determine the acceptability of the investment. Now it is similar to what we have solved before, right? Now instead of calculating a net present value P, here you have to calculate a future worth. That what is a future worth of a project. Okay. Now, how do we calculate a net future worth of the project? We have our formula same which we used before as well. We are going to use the same for this questions as well. How do we find a net present worth of this project? For example, we have a cash flows in year 0, 1, 2, 3, 4, 5, right? And what is an answer? You can take them each one by one and calculate their present worth, right? For example, I'll just put the here cash flows. Uh, And if you look at the cash flows in year 0, it is in this question. In year 1, it is minus 55,000. Sorry, year 0. Yes. If you look at this one, this is what we used to solve it before. We used to solve here net present worth. So now what we will do is, in this question, we will calculate net future worth. Net future value or net future worth of the project. This is what we are going to calculate. Meaning not here, you have to find net future worth. This is how you calculate a net future worth of the project. Now what is a net? Let me add something. Okay. So how do we calculate a net future worth? First of all, what are the cash flows in this project which we are looking at it in this exercise? We have year 0 minus 55, then year 1 42,500, here 42,500, for year 2 it is 44,600, year 3 it is 42,800, okay. Year 4 it is 42,400, just 42,400, and year 5 it is 42,100. So in this question we don't have to calculate a P, right? So we don't need this one. So what we need to calculate is the F for these 5 cash flows. So how do we calculate net cash flows, right? So what we are going to do is we are going to calculate the F for each of them, right? How do we calculate an F? The project life is 5 years. It's just going to. So now what is the future worth, right? What is the future F of each of these cash flows separately? And we know the formula F equal to P times 1 plus I to the power N. And N is different for each of them. Let's say what is the F for first cash flow, which is 42,500 here. What is going to be the F of this project, right? Let me put it here. Okay. So F of this one, because you have to calculate one by one for each one separately. These are not series, right? So you have to use this formula to calculate an F for each project, for each year. So for first one, F equal to P, this is what is the value of this amount, I is 15%, to the power n, n is 1, so this is the future value of this 42,000. What is the value of this one as of today, right? Similarly, what will be the future value of this amount, which is 0? Let me. Okay, sorry. So, sorry, my correction here. What, yes, what is the value of n in this question is going to be, yes, I need some answer here. What is the value of n for this one, for year one, after, if you are here after 5 years, right? So it's going to be 5, right? Yes. F equal to P, present value 42,500. It's 6, yes. Yes, sorry. Now, after 5 years, what is the future value of this amount, right? So, using this formula, P is 42,500, I is 15%, N is 5. Because after 5 years, right? How many years from here until here? Like, there are 5 years. Similarly, for this one, our cost, what is the future value of our cost, right? If you calculate a future value of this amount, okay, I'm just, okay. Okay, let me put the formula, then I will explain each one by one to you because it needs some time to add a formula here. Okay, I'm going to explain now what I have done. I am going to explain to you the formula which we used it. Are you there? Yes. Yes, please. I hope you can hear me now. Yes. Okay, okay, thank you. Thank you, Nasir. Okay, now see what we have done. I'm going to explain to you how to calculate a feature value. See, first of all, what is the feature value of starting from this one, cost? What is the feature value of this one? Right, feature value is P, which is 55,000 negative times 1 plus I is 14%, and N, what will be the N? You are today here, right? So at the end of year 5, basically what you are calculating is what is the value of this minus 55 here at the end of this one, right? So this is how you are calculating, right? So future value of this amount, right, at this time. Okay, so what we have done is we have calculated a future value of this amount which is at the end of year 5. Let me see why it is hanged. Yes, okay. Okay, so the future value of this amount, this one, this is basically at the end of year 5, right? So if N is 5 years, you calculate. Similarly for this one, what will be the value of this? What will be the value of F? Is this amount, right? Value of this project is 71,181. Means after, what will be the N for this one? Until here. So it means including this year, end of year 1, year 2, year 3, right, year 4 and year 5. So you are going to have a 5 year, for this one you are going to use N as 4, for this one because it was in year 0, so end of 5. And understand, right? N is 5, here N is 4, 3, 2, 1 and N is 0 because you are in the same year, year 5. So 42,200, that's why you have same amount here and here. Okay, so then you calculate this amount, which is, and so this is our net future worth, right? That at total our net future worth for all of them is 178,119, right? This is our answer approximately, right? Now any question? This is very important, how to calculate a net future worth from anyone? Is it clear? Because the only thing is how you put an N. This is very important, right? Rest is very easy. Okay, okay, thank you. So now we are done with this one, question number 16. This was question number 16. So 15, 16 is done, right? Now next is question number 18, right? Which is, again, I'm going to share my screen with you. Now question number 16, question number 17 is similar to 16, but it's many project in one question. 17. Consider the set of investments which have a 3-year investment life. So you have a project A, this one. This is for, so you have to solve this as a separately one question. Project A is a one question. What is the future worth? Project B is similar. Project C is another cash flow where you have negative at different point in time, and project D. And you are required compute the net worth of each of these projects at I equal to 15%. Which projects are acceptable? So which projects are acceptable? It is a same concept, right? That any project which has a positive net future worth will be accepted. A project having a net future worth as positive accepted, negative will be rejected. And then part B says compute the terminal project balance for each of the project I equal to 15 and compare them with the net future worth of the project. What conclusions you reach? Now I will share how do we calculate a net future worth or a project balance. So let me share with you 5.17, right? Question number 5.17 with you, how to calculate a net future worth of this project, right? How do we calculate a net future worth of a project with the same method? Let's say we are going to take any one project. I'm going to start with project number A, right? And if I enter the value for, let's say this is project A for 17, for project A, and we have to calculate a net future worth of this project A. In year 0, what are the cash flows? In this question is minus 12,500. So I'm going to update 12,500. Then year 1, 6,400. These are the cash flows of project A. Year 2, 14,400. Year 3, 7,200. Not here we have nothing. Let's say N is going to be 3% and it is going to be 15%. And 3 years. Okay. Now this is what we are going to do now with this project. It's a 3-year project. Cash flows are given and you are asked to calculate what is a net future worth of this project. This is the answer, 13,974 if the interest rate is 15%. Yes. Now for this one, n is 3 because it is 3 years. This is for n is 2 years. You're using this formula for each one separately. For this one, it is n is this is n is 2, n is for this cash flow, right? First for this cash flow, n is 2. For this one, n is 1. For this one, it is in 0 because it's the same year in future. So now you have add is 13,974 is our answer for project number A. So what I suggest you to practice it by your own. You have the solutions, right? I just explained the one, but you can practice on your own. I'm going to share. Yes. Now, if you look at here, what is the future worth of each of these projects at 15%, right? This is the answer. We have it on from the solution manual. First one is minus 12,000, and what is n? You can see here on the screen it is 3. For 6,400, n is 2. For 14,000, it is 1, and for next one, it is the same amount because n is 0 in this amount, right? So 13,213 is our answer for project number A. Similarly, you can calculate a present worth, a future worth of project number B, project number C, project number D. Okay, this is how you calculate a future worth. Why we need to calculate a future worth? I'll introduce something else here as well. If you look at next slide, for project A, I'm just look at an answer of project A first. Very important. Project A here. See here in project they say what is the project balance of each year. What is the purpose? This is similar to payback period, discounted payback period, same method. We are just repeating. Only the last column is the project balance, right? There is a relationship between payback period and this one, this formula. It's going to have the same thing. Now, if you look at project number A, cash flows in year 0 is minus 12,500. There is no interest earned. So the balance of the project is 12,500. Okay. Now, similar to discounted payback periods, this is the cash flow in year 1. Now, what is the interest earned means 15% of 12,500. So it means that this is what this project must have earned, 1,875 for year 1 cost, which is the balance was 12,500 times 15%, you get 1,875. I'm repeating, this is the same method of discounted payback period, which we have already done before. How we get this 1,875, right? This is from this number here, if it's not clear. 18, this 15% of 12,500, right? So if I'm just going back just to show you, if you don't remember those beginning question, if you look at 5.6, it is similar. If you look at this 5.6, how we calculate in a discounted cash flow method, this was the method, right? Interest earned 5.6b, or we already solved an example. This is exactly the same what we are doing. If you don't know, you can go back to these slides. sorry, so let me see what is it. Just a minute. Okay, is it clear now? Okay. Now see, this is what we are doing. We are repeating what we have done in example 5.3. How do we calculate a payback period? If you don't know, you can come back and look at this slide again, slide number 20. And also you can come back and look at slide number 24, right? It is exactly same thing in this question, what we are doing right now. How do we calculate a net future worth or a project balance? It is same thing. So if you look at 5-17, right, for project A, just one question as a separately, right? If you look at this one, it is exactly same thing. So when you calculate a project balance, see the last answer, it is 13,213, right? And if you look at same question, part A, future worth of a project at 15%, it is same. See, whether you calculate a future worth of a project or if you calculate a project balance at the end year 3, it is the same amount. Look at the last number here in project number A, 13,213 is same as what you have done before here, future worth of a project. Okay, why we need this one? If you look at here, for example, middle of this project, after 2 years, for example, you want to sell it to someone, right? You want to exit from this project. So let's say in this project number, you want to close a project and want to sell it to someone else. You should sell it, for example, what is the value of the project? 5,229. This is the amount at which at least the minimum, right, which you should sell it. This is the value of the project, right? Because you are going to make a profit of this project. So from another party, this should be your minimum or maximum, up to you. What is your bargaining when you want to exit the project? This is the scenario. For example, you want to close a project after year 1, but in year 1 you are making a loss, right? So when you negotiate with that one, so at least you should cover your loss, right? And if you sell a project in year 1, you are still losing, right? So you have to make sure when you close the project, this is the purpose of calculating a net future worth, that if you are exiting a project in that period of time, what should be the bargaining price. So is it clear how to calculate a net future worth and how to calculate a project balance? Yes, anyone has a question? Yes, please. Anyone has question? Hello, can you hear me? Okay, thank you. Now 5-18 is next question. Now what is 5-18? Next is question 5-18. If you go back to your exercises, right? Now it says, which of the following investment option will maximize your future worth at the end of 8 years? Assume any funds that remain invested will earn a nominal rate of 12% compounded monthly. Now this question is basically a summary of chapter 3, 4 and maybe 5 all together in this question 518. Now which of the following investment option will maximize your future worth at 18 years, right? So your 12% compounded monthly, right? Now this one, it means it is, if you look at this one, this is slightly a different question. It means you have to use, in this question, you have to use an effective rate, right? And to calculate an annual effective annual rate for each situation. Now if you look at first one here, deposit 8,000 now, right? So then you need to know what is your annual rate, because after 18 years, what is F? You have to take each part separately and calculate an F. For this one, 8,000 now, what will be your effective annual rate? You have to calculate an effective annual rate. I think 12% will become 12.68. We solved it before in chapter 4. So your interest rate I for this one will be 12.68, and then you can calculate an F equal to P, which is 8,000, right, times 1 plus I to the power n is 18. Very similar. Only thing is I, which you need to calculate. Right, so this is your 8,000 now. P, your n will be 18, but your I, here you have to calculate an effective annual rate. 1 plus R over m to the power m minus 1, that formula. You should have 12.68, I think. We solved it for part A. I'll share the again solution. If you look at here in this exercise, I see I is 12.68. So then using our basic formula F equal to P, right? 8,000 times 1 plus I is 12.68 and it's 18. It is going to be 68,601. This is the future worth. This is how you calculate a future worth. Okay. So for part A, see, I will just put it here. For part A, I equal to 12.68%, N equal to 18, and we can calculate F equal to, for part A, this one is for part A, F equal to P, which is in this question 8,000 multiplied by 1 plus I is 0.1268 to the power 18. This is how you do it for part number A. You should get the same answer, right? Right. If you solve it, your answer should be 68,601.42. This is the answer for part A, for this one. Similarly, for part B, let's look at what is the scenario for part B. Now part B, deposit 120. Now this is chapter 4. deposit 120 at the end of each month for the first 12 years, right? Deposit 120 at the end of each month for the first 12 years. How do we calculate a future worth of this one? I'll explain. 120 for first 12 years. Let me open just a minute one Excel file. I'll explain. We'll just continue for maybe 20 minutes more if you want. Then we'll finish a class early today since you have exam today. So give me next 20-25 minutes and then we can finish early today. Is it okay or you want to take a break? Okay, okay, thank you. Okay, now if for this one, now in this question, part B, deposit 120 at the end of each month for 12 years. So if we deposit 120 for each month, right? 120 each month until for 12 years. So 12 years means how many months, right? For 12 years, because this is monthly. So how many months will be there? For 144 months, you deposit let me share my screen with you what I'm doing. Okay, now if you look at here in this question, you deposit 120, 120, 120 for how many months? It says in a question you have to deposit this for, right, for 12 years. For first 12 years, you deposit at 120, 120. This is basically your 12 years, right? This is a little different question. 12 years or 144 months. In terms of months, it is going to be this one, right? But the question says, what is the value of this amount of money after 18 years, right? If you look at a question that first deposit 120 at the end of each month for the first 12 years. What is the value of this amount of money after 18 years, right? This is what the question says, that for first it is here, right? So in that case, and our interest rate is 12% compounded monthly. So I'll say here 12% compounded monthly. Yes. So how do we calculate? First of all, so basically our time period will be, you can see here, 12 multiplied by 144, right? If our R is 12%, what will be our effective rate? First of all, this is what we need to calculate, our effective rate, right? And then we can calculate whatever amount we have, right? So we have to calculate an effective rate, right? Effective monthly rate, right? Compounded monthly. So in this case, what is the future worth of this one? This is basically the question. So first we need to calculate an effective rate. I'll just show you. I'm not solving it here. What is R in this question? R is 12%, C is 1, and K is going to be 12, right? So use this formula, right? So to calculate an effective monthly rate, which is, understand? So in order to use it here, we need to have an effective rate, right? How do we calculate an effective rate? Using this formula, 1 plus R over CK. Can you calculate? Someone give me this number. 1 plus R, R is 12%, C is 1, K is 12 because it is monthly payment and it is compounded monthly. So C is 1, K is 12, and if you solve it, right? Yes, what will be effective rate, right? Can you give me an answer of IA, effective rate? 0.126. No. Habib, this is monthly rate. My answer should be 1%, 0.1% something. No, 12% compounded monthly. Now I need my monthly rate. Yes, it's close to give me 4 5 decimal places. Yes, Akram. Yes. See. Yes, is it 1%? Yes, okay, thank you. Okay, exactly. Okay, thank you. Okay, so I is 1%, right? Now, can we calculate a future worth? Can we calculate a W? Oh, sorry, F of this amount? F equal to what will be the using this formula here? You have A is 120 times 1 plus I. I is this one, effective rate, 1%. And what will be the power of N? Minus 1 over I. Can you give me the answer? Use your calculator. Yes. A is 120. A is 120. It's given. This one 120 and monthly amount. Your N will be 12 years, so 144 will be N. So this is your A. This one. 120, 120 every year. Yes, N is 144. Calculate an F. Times 10 power 45. 1 plus I to the, see, 1 plus the final answer. Okay, Akram. Yes, 38,287. Can someone double check? Yes, I equal to 1, N equal to 144, A is 120. Yes. Okay. Okay, now this is the value of f after 12 years. Remember this one. After 12 years, this is the value. But the question says, now this is what you need to understand. Now, what is the value of this amount after 18 years? Meaning that if you start today, this amount of money, after 18 means you need to go for 6 more years, right? 2, 3, 4, and right. So if you continue with same amount after 6 more years, right? So basically total this will become how many? You had 12 years before and 6 years more, right? How many total you are going to have? This is basically how you have done. This is something we done before, right? Now for first 12 year it will grow and it will become this as of today. See, this is our amount, right? It will continue to grow, right? When it is compounded annually. 120 compounded annually, sorry, 12% compounded monthly, and then from here to here, from this region, right? From this region, our I is 12%. Now this is only a little bit different questions. Okay, so for I 12% from these 6 years. So basically what you do is for first 12 years your 120 has become as of end of 12 year or as of today you are now, and then you continue for 6 more years. How much it will be there? Every year you deposit some amount, 120, 120, 120. You do it for first 12 years, right? Means for 144 months it will be this amount, right? And then you calculate a future amount of this one, right? Now this is your 38,287 is your P, and your N is 6 year. So I is 12% using F equal to P times 1 plus I to the power N for 6 years. What is your answer? Can you calculate? I'm just stuck here. Yes. Yes, now can you calculate? I just write here a formula, right? F equal to P is the answer you gave me, 38,287.387 multiplied by 1 plus I is 0.12 to the power 6. Yes, I just typed it here. Can you give me an answer here? This is the answer of your F. Yes, can you give me an answer? What will be your answer? Yes, please, can someone else check the answer and confirm this is correct? Sorry, make a small correction, sorry, because you have to use effective rate, sorry. So instead of this one, use 12.68. Sorry, our effective rate is 68. Yes, sorry. So make a correction here in this question. It should be effective rate because it is compounded monthly, the given one. So we need an annual rate which is 12.68. Sorry. If you just replace it with this one, what is the answer? It should be 78,000 something. Actually, for me, it's hanging, so I cannot do anything with this one. It's just hang, it's not changing. Okay, yes, sorry. Okay, now it's okay. So 12, sorry, because it was annual, so effective annual rate, this is what we need to do is, yes, it is 78,367, right? So this is how you calculate. Now I will repeat this question again, right? So in this question, first what we have done is we have calculated a future value of 120, which was for every month for 12 years, right? So in that case, what we have done is we use first of all, we have to use this formula F equal to A, right, to calculate a future amount of an annuity, right? And we know how to calculate that number, right? We use this formula, right? And in order to use this one, A is given 120. I, we have to calculate the effective rate, right? So monthly effective rate, after converting it, it becomes 1%. N is 144, and we find out that our F is this one. But the question says, what is the value of this after 18 years? For that one, after 18, then we calculated this one. If you look at a solution in a book, they continued with the months. You can do the same thing as well, right? You can also continue, instead of next 6 years, you can put next 6 months. Oh, sorry, 36 months. You know, from here to here are months, and then you can calculate 1% as a rate. You can do it also. If you put same question, if you put, let's say, instead of years, you can, if you put months here, you can do the same thing also, right? Let's say I'm just putting, it will be a correct, instead of years, if you put months here, so what will be your N here will be, for next 6 months means 70, 12 times 6 is 72 months, and your I will be 1%. This is also correct, right? If you do it like this one and calculate an F of this amount with the same formula which you have just discussed, you will get the same answer, right? If you use 1% and 72 months, you can get the same answer. You can check. Yes, so you can use the same formula what we have done before, right? I'm just typing it here in the comments section, right? If you put this as an I as 0.01 and instead of 6 it will be power 72, right? You can check this answer. What will be your answer? I just type it. It should be same. Just double check. You can do it in this way as well. Yes, Akram, can you confirm me? Or Ahmed, if you are around. And then we are going to finish our class. Yes, Abdul Mohsin, thank you. So it's going to be, you can see it's almost around same amount. Yes, yes, we are going to have same amount. So it's up to you. Understand, when I use 1%, I use N as 72. When I use 12.68, is okay. So only thing is understand, when I use 1%, I, right, look at my time period months. So interest was monthly, and this one, when I used yearly, it was my effective yearly rate, which was 12.68%, right? If you want to compound it, for this one from part A. Okay, so now if you look at, this is what we have now on our slide. The solution is there. You can check with whatever method you want, right? You can. Okay, so 5.8, part A, part B, part C, and D is similar, where you have to calculate, right? In part C, it is, we just only this was difficult. Part C, deposit 105 at the end of each month for 18 years. So for continuously, so you don't have a complication like what you have in part B. Part C is simple. A is 105. So 18 years means 18 times 12. So you calculate F equal to A, that formula. And part D is deposit a lump sum for 30,000 at the end of year 12. For that one, 35,000 at the end of year 12. So this is 12.68 your annual rate. And year 12, then after 12, how many years is 6 years, right? So you have to take 6 years and then calculate and see where you have a maximum of F in all of these values. So option C is better, right? Because it gives us the maximum value of I. This was the question, which option is better? So this is end for today, right? So just look at some other slides. If you learn this one, the rest is easy, right? So only focus on the question which we solved until today. So in exams, you will have until what we solved today. Okay. Question, last question is this one, machine A and machine B, which is simple. Which machine is better? You calculate a cost of both machines and see which gives you a less cost, right? Similar, present worth. You calculate a present worth. Same thing for 41. You have to select out of two projects which is better. And this one 26, just ignore it. I'm not going to, it will not be in the exam. As well as this question 19, right? 19 and 26, ignore it, right? 17, we already solved it. So you can ignore 19 and 26. 41 is easy, calculating a present worth, and this one. Okay, so that's it. Best of luck for your exam. If you have any question, just send me a WhatsApp message. Okay, thank you very much. Those who want to leave, they can leave now. If you have any question, please ask now. Yeah, yes, Ahmed, it's okay. Okay, so that's it. Those who want to leave can leave, or if you have any question, I'm here. Exam instructions, everything is on Blackboard. It is there. Okay, so if no more question, we are going to end our class. Thank you very much. Yes, you said no, exam time was not 3 p.m. It was at 4 p.m. exam time as per the schedule. This is the instruction, right? Exam availability will be, I'm just giving because as per official it is 2 hours. We cannot give exam time more than 2, but I'm giving you 15 minutes before and 15 minutes after as an extra time to start the exam. Duration of the exam is 2 hours. No, 3 p.m. no exam. Exam will start at 4 o'clock. You can start the exam at 4 o'clock. Exam time is 4 to 6, but just in case someone wants to start 15 minutes early, it is there. Exam will be there. You can start your exam at 4 o'clock. Yes, Abdul Mohsin, I'll come back to your question. Just a minute. Yes, Ali Muhammad, is it clear now about exam and Eid al-Tabi? Okay. Abdul Mohsin, about your question that how you can change from years to months, right? How to change from 12% to 1%. We have a formula 1 plus R over CK, that formula which we have to use, right? For yes, the percentage, yes. 1, let's say in this question, we have a formula 1 plus R. What is R? If you have a calculator, you can do it. R is 12%, right? It was given, right? R is 12%. 1 plus R over CK. C is the compounding in a payment period, right? This was compounded monthly and the payment are monthly. So in this case, C is 1 and K is 12, right? To the power C, C is in this question 1 minus 1. So you are going to get 1% is the answer. This is the reason. Is it clear? Okay, okay. So this is how we have done it. Yes. And yes. Okay, thank you very much. Best of luck for your exam.